my name is Jason Meaux. I'm the founder and organizer of the PyTorch ATX Meetup group. I'm just a quick bio. I'm a mechanical engineer by background, but I've been spending the last couple of years researching state space models, if you're familiar with that. And my current project is looking at how alternative architectures can be applied in robotics. Yeah, so I'll get my slides pulled up here. Right, so I'll just kind of kick things off. I'll quickly introduce some things about the PyTorch ATX meetup community here, and then sort of talk about this question that I thought was maybe an interesting way to start things off, this why Texas question, and then try to connect that to Triton, and then we'll continue our great lineup of speakers. So what is PyTorch ATX? We're a fairly new meetup group in Austin that started last year. We focus primarily on the core ML stack, so model architectures, data pipelines, hardware, really everything in between, training models, running inference. The goal of the group is really to provide a space in Austin where technical folks can come together, share research ideas, discuss experiments, provide feedback on our work, and collaborate ultimately on projects. Just a point, PyTorch is in the name of the group, but we will not chase you out if you use TensorFlow or JAX. We are welcoming for all frameworks here.
Ooh, I was worried.
Yeah. I'm glad we could address that. So a few just recent topics, so that'd be just to give you a sense of what the group's been doing. I wanted to run through just a couple highlights. First one, Scott Maddox is here. He worked on the Nano GPT speedruns. For those of you who don't know, I'll just in a very clumsy way just describe what that is. Basically, it's training GP2 size class models and tracking how fast we can train them with certain optimizations and for them to reach a certain loss. And Scott worked with a team that worked with, among other things, the Meaux optimizer, and they were able to get a state-of-the-art, record-breaking speed run. That was a very interesting presentation. We've also covered alternative architectures, BERT classification tasks. Jake did a really good presentation on that. And then Kshitij Agrawal did R10 reinforcement learning reasoning experiments. So that's the kind of work we've reviewed recently. We also have a paper club format, so that's kind of a little different than a normal meetup where we would get together and just talk. This is more, you read a paper beforehand, we get together, there'll be a paper captain assigned, and we'll do a deep dive on a single paper for at least a couple hours. We've recently launched the robotics paper club format of that group. A couple weeks ago, we reviewed the physical intelligence Pi0 paper. I think on Sunday we're doing a path planning session. If those are the kind of things you're interested in, just look out for our events on Discord, Meetup, and welcome to the PyTorch ATX community if you're new. Before we get started, just really want to recognize a couple shout outs. Number one, our sponsor, Red Hat. This is the largest meeting we've done, a lot of hard work to get this planned. Especially want to recognize Kara with Red Hat and Catherine Henry with PyTorch ATX, a lot of hard work on organization. And then of course for Steve for having the vision for getting everyone together for this purpose. Yeah, so a quick presentation just to kick things off. It's not entirely technical. I thought it'd be fun kind of thinking about this question. We do find ourselves in Austin, Texas here. And I thought it might be interesting to think through what are some of the reasons Texas might be positioned to play sort of this outsized role in this new era of computing we're heading towards, and in this massive build out of data center infrastructure that's coming, and then try to connect that to sort of Triton, the Triton idea. So we're going toward this era. We're rapidly building out training and inference infrastructure to support just these massive machine learning workloads, really at scales we've never really seen before. I think maybe we can, like, very simply just think about the development sort of in these three layers: the software, hardware, and energy. So in terms of like Texas, there's quite a lot going on in all three. Obviously for software, there's a thriving ecosystem here in Austin, as well as throughout the state. Tons of developers here doing really cool stuff. That speaks for itself. This room speaks to that. The hardware layer, of course, Texas has like a really long history in that, going back to Texas Instruments and even before, and basically every major player, especially if you consider sort of the regional impact. So if you include Texas and its neighbors of Arizona, New Mexico, everyone you can think of: Intel, AMD, NVIDIA, Samsung, whether it's fabs or manufacturing plants or just engineering centers and talent. There's quite a lot going on in Texas for hardware. But maybe we can just focus on this last category for the next few minutes and talk about energy and why Texas is kind of in a unique position there. So it's really hard to overstate how dominant Texas is in energy production. Earlier this year in January, for example, we in this state produced over 50,000 megawatt hours of electricity in that month. This is more than twice as much as the number 2 and number 3 states, Florida and Pennsylvania, and over 3 times more than California. To break it down a little bit, Texas is the number 1 oil producer, number 1 natural gas producer, number 1 wind energy producer for 18 years straight, and the number 2 solar energy producer, second only to California. And even for solar, that's quickly kind of chasing, especially in the last couple of years. Texas is super aggressive at adding solar capacity to the grid, especially for grid scale projects. So there's this kind of energy dominance in the state here, and maybe we can like break that down into a couple of categories. The first one would just be like the state is just blessed with these natural energy resources. So for wind, you can see Texas there on the map is in the dark blue. It just sort of stands out, like no one is anywhere close to the wind generation capacity in Texas. A lot of that has to do with just very high wind environments, especially like in the north part of the state, the west part of the state, as well as the Gulf Coast. Sustained wind speeds like 15 to 20 miles per hour, gusts up to like 35 miles per hour and even greater. This is just like very good place to build wind energy projects. Same thing for solar. Really you can see that entire like Midwest, but Texas has a lot of like some of the highest solar irradiance, which is just sort of like, very sunny place, but like what is the intensity of that sun exposure, and how efficiently can you translate it into electrical energy? So the potential for solar in Texas is also extremely high. And then natural gas, very important for the state and for the energy grid here. Texas produces so much natural gas, most of it isn't used in Texas. Most of it is exported for energy needs in other places. So you can see Europe takes quite a bit, Asia. Texas now supplies quite a bit of Mexico's electricity. And then of course other states. The remaining natural gas here is like, very important for baseload power to the electric grid, also for heating Texas homes and for industrial use cases here. So we also benefit in this state from a very unique regulatory environment and business environment. So I'll just start talking about the first bullet point here, the independent grid. The grid is managed by an organization called ERCOT, the Electric Reliability Council of Texas. This is like sort of a very interesting situation. Texas is like considered to be on kind of an island that has pros and cons, but a lot of pros. The reason what does it mean to be on an island? It means that we aren't connected to other states' grids, which is a very odd thing. Most states integrate their grids together. So this was actually done on purpose. It was done in Texas to avoid being subjected to the Federal Power Act of 1935. This was a piece of legislation that granted the federal government oversight on interstate electricity transactions and systems. So by not having our grid really connected to other states, we basically just manage things ourselves here. The advantage is we avoid a lot of the federal red tape for like any energy project that comes up. So we avoid sort of that, that extra layer of bureaucracy. And so our faster deployments, our energy projects here can often get from like moment of conception to actually the thing getting built out and then put like into the grid. Like this can happen in a period of only 2 years. Other states, it's much longer. It could be 4 years or even longer, 4 to 6 years. That's like a really big deal. And then the business environment, is very good here, from a personal and corporate income tax standpoint. We don't, the state is attractive there, and generally like local regulators are willing to work with businesses to like make things happen fast. Maybe like I could say more about that, but we could just like summarize it in a meme made famous by Noah Smith. Texas is the state that builds. So how does this connect to like we're here for this Triton conference in AI? I mean, it connects because there's just this massive build out that's in the works. Maybe like the sort of more eye-popping one earlier this year was the announcement with OpenAI, Oracle, and SoftBank with the Stargate project. The headline I think everyone paid attention to was $500 billion of investment. But really like for us, we're interested in energy right now. So really the number that should have jumped out at us was 5 gigawatts of capacity. This is just like massive scale, 5 gigawatts. So just give you an idea, like 1 gigawatt can power, over 1 million homes worth of electricity. So we're talking about, 5 times that much. This site is actually getting built. The initial site is getting built in Abilene, Texas, which is between Dallas and Midland. This is just a great area of the state for having access to plenty of energy. That's just one project. Probably long term to medium term, the demand could be in the tens or even hundreds of gigawatts worth of data center build out. And ERCOT's aware of this, so they're actually anticipating 150 to 200 gigawatts by 2031. This would effectively like double the electric grid capacity demand, which is just sort of an insane thing. I mean, Texas already produces, by far the most electricity. And if you're like, ERCOT is like literally planning a queue of projects to meet this demand. And there are really like few places in the US or even in the world that could be credible enough to actually pull something like this off. So Texas seems to be this place where build outs like this are actually possible. And so a lot of projects seem to be coming to Texas. I'll just say one more point. Like the one power source we haven't discussed is nuclear. That is like probably holds a lot of promise. There's a startup here in Austin, Texas called Allo Atomics. They're doing small modular reactors. The current governor of Texas is like extremely bullish on deploying nuclear in the state. I think like probably a little bit as we get closer to 2030, this is going to be a very exciting potential X factor for the power grid, and especially the modularity of these systems. If you can build them in a factory, get them to site, and get them set up quickly, that's going to be another place to scale and another benefit for the Texas energy system. but kind of like getting back to sort of maybe the 3 layers here, like getting back to software. After we build these data centers and get energy hooked up, like really a tremendous amount of focus is back on the software layer, back on the hardware layer. And just to give you an idea of like why that's important, if you can imagine like 10 or 20 gigawatts worth of inference workload here, like if we can write kernels that help us optimize, even 10 or 15% more efficiently, it is just tremendous, gigawatt scale energy savings potentially over the long term, and more than just energy savings, like being able to deploy these models and this technology to more customers, more people. The software layer has never been more important. So with that, perhaps we can transition to the Triton presentations and talk about that software layer. And looking forward to hearing everyone's talk. Thank you.